So this is me. I have about 20 something, 24 years of experience, and I've done hardware and software in my life. I've done many devices. This is the first Android device, not this one. I actually made the snow reconnaissance. The first device that I made is this one. It's basically, as you can see, there is a screen on the button, and this is basically a full Android device that obviously on your ski slopes, and it has apps, it has maps. You can control your music using Bluetooth. You can get phone calls, all this stuff. I made two products. I made Snow 1 and Snow 2, and then I made the Recon Jet, which is basically a sunglasses. So this was from 2011 to 2014. But then Intel bought the company. Brian Korzik tried this on and he loved it, so he kind of pushed to buy it. I also made this product Sightfolder recently, which is basically a keyboard, and the computer sits here. This is Android 10, and then we upgrade 11, and then we upgraded to Android 12. This is the glasses using Unreal glasses, and there is a trackpad here, and this is what you see basically. So this was obviously before Apple announced the stuff, but this is Sightful. This is has been launched, and you can go on the website and they sell it. Another product I recently did is basically NavGuard, which is sitting on a drone, and it has a camera, and you can basically tell the drone to go someplace, and it's using a camera to go, so it doesn't use any GPS or RF. It's basically an offline device that can use vision to track. So you can tell to go to a target and come back, collect some information. I've done patent. This is a patent I did for a keyboard on a heads-up display. So basically, this is the keyboard. It kind of arrange A, B, C like this, and then when you move right, the entire keyboard is moving. As you can see, you click on the mouse and keyboard, you click right, you click up, the entire keyboard moves. You always in the center, and the keyboard moves around you. This is better than QWERTY even on PS3, PS4, Xbox, whatever, all these things, because the length to the farthest key is only 1, 2, 3, 4 steps. So this is basically to do navigation. I've done website. This is basically a potluck website that I did. I've done. I'll show this in a second. I've done social apps. Lipsy, we had 4 million users. I've done. This is a website. This is basically a course I made about Kotlin. You basically build this Kotlin weather app. It's on my GitHub. You can try it out. It's basically using all the latest stuff on Kotlin. It changed a little bit. Obviously, this is from 2019, but it's still very, very relevant. I've done an app called Weather on Chromecast, which I disconnected because the API calls were too expensive, so I had to disconnect it. But it basically, if you have a Chromecast, you have basically a phone, and you can basically cast your location. So if you're in Tucson, you can cast your location, and basically this is what appears on the TV. So you have like the weather, the next 12 hours, then the next day, and how it is. So it's continuously changing, so you can leave it as a background. What else? I built the RFID modem. I built many stuff, and the latest stuff that I built that you obviously used is Fronts AI. This is what you tried on. So it's basically a website builder. Obviously, you can book meetings and sell services, and these are basically the sessions that we have, and I put it on my website. Fronts AI is basically a directory that you can see here to all these basically websites. So you can see, I think I have Brazil. Do I have Brazil? I thought I had. Maybe I don't. But yeah, I mean, you can go to any country or any tag. So if you're looking for a developer or you want to add yourself, this is totally free. So you can, so give a second. Okay, so we are back, and we'll start with the first chapter in the Android 12 internals class. There are things that I will skip, but most of the things we'll go over. So let's start. So the Android open source project is the official source code from the Android operating system and can be found in this link. You can see basically that Android is made out of what's called different projects, different repositories. Each one is basically its own Git repo that you can clone. You can see that each repo that made it out to the main branch, the master branch, some of them are being depreciated, but each one has its has the tags that has been used to mark basically the release commit. So that way, when you check out Android 13, that will come out with that commit. We'll let's go back for a second to the material. When we download the Android source, and obviously I download it to you, for you, basically, this is the command I've used to download the Android source code. So I use the tool called repo, which basically is a tool to download, to create a manifest, and by that you can download a bunch of Git repositories that can be tagged, or can be you can tag them, branch, whatever it is, and that way you can take a bunch of projects and download them in a specific state. Okay, so this is basically the manifest of all the project, and you ask it to give you. We work with the Android 12 release 15. This one is basically the one I found to work with the Cuttlefish we work in, and we'll talk about the Cuttlefish in a minute. But once you set that up, and you can see here, I don't know if you've seen the video, it's a quick video.
Now we can create an AOSP folder for our source code download location. From the course material, copy-paste the repo init command to initialize a checkout of the master branch of the Android source code. This information is also available in source.android.com in the Setup tab under Download. You can see in the instructions on how to download a specific branch using the -b flag. Also, it is possible to use the partial clone flag to only download what you need for the build. After initializing the repo against the master branch, you will see a Git error that you can choose to ignore. If you wish to git config your email and name, go ahead and do that now by running the git config commands with your email and name. We can now download the actual source code by running repo sync along with the number of cores appended to the -j flag. Again, I will speed things up, but this process took me almost an hour to complete on a strong Wi-Fi at home. The resulting virtual machine is about 190 gigabyte. This is obviously without building the source. Running du with depth of 1 shows that the AOSP folder takes about 115 gigabyte.
Okay, so that's downloading the code. We skipped almost all the stuff, so we'll talk about, I'll go over the source and the developer in a second. Okay, so our 2 websites that we'll talk about in the course. And the first one is developer.android.com. You can also write theandroid.com. Okay, same thing, the developer. This is for app developers. This is where they usually go. They go to Android developer.android.com, and they can say, "Oh, how do I create an app of that and that?" So it's targeted for app development, and it has basically the API that is used to talk to Android. So basically, in developer.android.com, in the reference folder, you can go and check out the API reference. I clicked on overview here, and this is basically right now there is a version 34. Okay, so this is the latest version. I don't remember what is real, maybe the new version, but you can see every Android API since version 1 to version 34. This is basically, if I look at a package called a class called vibrator. Okay, so this is basically what causes the device to vibrate. Okay, so this was introduced in Android API level 1, and I can go to the public methods. Okay, so the public method, and see what was released in Android 1. So so it's not updating. So let's try maybe something like that is supposed to show up. I don't know why they don't. They're supposed to hide all the stuff. So maybe I need to look at that. Okay, so anyway, so let me go to version 6. Usually, I don't know what happened, but usually those functions disappeared when you click on one of the version. But you can see obviously the classes. Why this was supposed to cool to see which functions were added, because they started with one function, and then in Android 10 they added Android 10, yeah, they added has vibrated because Android 10 started with tablets, and then later on they added these functions, the vibration effect, and so on. We'll get back to how this is actually flowing in Android, but basically this website, the developer.android.com, contains the reference on how to build app, including how to build the native apps, Android NDK, and so on. So this is for apps that are writing only in C++. All kind of information you can see, architecture, UI design, and so on. Okay. The second page, the second basically link that I want to show you is basically source.android.com, and this is more of a website for us, for Android OS developers. it tells you how to download the Android source code. So basically, you can see here, you can download Android 13 right now. Right now, it's the main branch is basically sits on Android 13. You can see here, okay, so you can see here the tags, okay. So to download the Android OS for you guys, you can see if you look at the history of what I've done here. So so basically, I've installed these packages. Then I download the repo tool to download the Android. Then I went to the AOSP, created an AOSP folder, and I've downloaded the 15 branch. Okay, so this is basically the R15, release 13. So here you can see that you can download Android 13, the latest Android 13. That if you get it at home, if you have a Pixel Fold device, you can build for Android 13, and if you want the latest for Pixel Fold, you download this version. If you have a Pixel 4a, I use Pixel 4a, a good device to develop cheap. The latest one that support, you would have downloaded that if you wanted to check Android. The OS that I use, Oxygen, not Oxygen OS. Is it Oxygen OS? No, not Oxygen OS. And Word OS releases. I use Lineage. Sorry, Lineage. Yeah. Yeah, Lineage OS basically gives you Android with a bunch of tools, a bunch of things, because once you download Android vanilla, so without, and we'll talk about what is Android vanilla in a second, but once you download that, you don't get too many apps. You'll see it in a second when you run it. And that basically replaces all the stuff for you, so you can download it for any of those phones, and you get Android, a bunch of apps, email, and all this stuff. I don't remember exactly what you get because I've done it once. But anyways, yes, Synagogue. Yeah, they have that. Yeah, it's supported. So yeah, so you get all these apps, camera app, audio, calculator, calendar, clock, contacts, music, phone, recorder. So all this stuff, basically, you get. Now, why can't you get it like that? Because when you build it like this, because using Android, it's because what Google wants to do is Google GMS, Google GMS Android, Google mobile devices. So all these apps that we are using, Gmail, Google Maps, push notification, Google Search, Google Chrome, YouTube, Google Play Store, all these apps, they don't come built in with Android. You need to basically authorize your device with Google, certify it, and basically then you can download it. So Android provides common device level functionality such as email and calling. GMS is not part. GMS is only available through a license with Google and deliver holistic sets of popular apps and cloud-based. So yeah, so you need all this stuff. And any question? Any question so far? Okay, so wrap back to source.android.com. We can download the source using the instructions I have in the course for Android 12, or if you want to download Android 13, you can go from here. It also tells you, and again, the material, also my material has this, but tells you how to build Android. And how to launch it. We'll talk about that in a second, and how to actually flash the device. And this is if you want to flash your device. Okay, again, I don't recommend to use raw Android. Use Lineage OS if you want to flash real devices. Okay. There's a lot of discussions about the security architecture and the kernel security, app security. We'll talk about all this stuff in the course. We'll talk about this material also. Source.android talks about specific modules, hardware modules like the camera, how basically the camera is designed. This by itself will not will not tell you too much right now, but after the course, you will understand what these things mean. So you understand what is those folders and what does it mean, what is a camera device, camera provider. Less that this is the camera, but you would be able to understand a little bit more about what these things are and what they talk about. After the course, you'll understand the architecture a little bit more to go and read those things. Okay, so yeah. Anyways, we'll visit those more. Okay, so it basically tells you about the security core topics, core topics, obviously, compatibility. Basically, I don't know if any of you did CTS and CDD, but basically, let me talk about that. So when you are customizing a real device, I don't know if any of you yet, maybe Etienne would want to, when you are basically customizing or creating a new device, you need to pass through a compatibility program. Basically, this tells you to follow the compatibility definition document. This document basically describes what an Android device can do or need to do or has to be, and so on. So, for example, if you look here, you can see multimedia capability. Your device must support the media formats, encoder, decoder, file types, and container format defined in this section. So it need to basically make sure that it has this support. Usually the end developer don't really deal with that. That basically need, when you get basically from your OEM or your from vendor gives you a device, they need to say that they pass CTS. What is CTS? CTS is a test that makes sure that you have this. The CTS is the compatibility test suite that you use in order to test Google, to test all this stuff. So it has basically a verifier. It goes and it checks the audio, it checks the framework, takes the API, it checks all this stuff. It does a lot of work, a few hours or days, I think. I think days, and for sure. And then you need to pass it, and if your vendor didn't pass it, you're in big trouble. So otherwise it's almost impossible to pass it. But anyways, we're not releasing any device, but this is some, you would have a full-time engineer just working on that if you are releasing a device. Yeah. So all kind of stuff about Android devices, about Android Automotive, and so on. Okay, so this is basically source.android.com. Any questions? Any issues? Okay, so this is hardware prerequisite to run the device, your hardware to compile. So not relevant for us, but you will need 500 or 500 gigs of space for sure. 16 gigs of memory is the minimum requirement. Okay, this is the instructions how to download. I've done that for you. Download Ubuntu, set up Ubuntu, set up a Linux build. So do all this installs, download the repo launcher, download the Android source code. Then you get basically the device folder. We'll talk about that in a second. I want to make sure that we okay, so we've done that, set access to virtual machine, set up the necessary for the AOSP source code. We haven't done that structure. We talked about this, we didn't talk about that, the device folder, okay. Okay, so let's look a little bit on what we've downloaded. Okay, so I will go a little bit on I will go a little bit on what what it is, and then close to the end of the hour we'll run the Cuttlefish. So we need to test it now very quick, okay. So what you see here is the different folders in Android. Most of them you never need to know. Art is the Android runtime libraries. Bionic is basically the custom libc that you have. Basically it's a libc. Android itself is not POSIX device release its own build. What does it mean? It doesn't have a Linux kernel, but you cannot bring a library in SO and run it on Android, but that's compiled for POSIX for standard glibc. Android has its own libc called Bionic, which is not compatible with glibc or your apps. That's why we will compile anything that you bring into the system has to be source code, and you have to compile it. You can't bring a library like an SO or anything like that. You have to compile it with the Bionic. Okay, bootable has will have I don't know. It's the recovery, the fast boot here. Yeah. Anyways, we will. I will focus on the directives we do care about. The device, the frameworks, the hardware, and the out. There's also things in the system that is interesting. You can see. Okay, so anyways, I won't get into that for a second. Okay, so what we focus on basically is this, the device folder. That's where we work, and we'll also have a vendor folder that we haven't created yet. The out folder, now the design of the build is in such a way that all these folders would not change. Okay, so they would not change during compilation. Out is the only folder that changes during compilation. So all the files, all the build files, all the files that I use in order to build will be in out. If you delete the out, you become you build you need. It's basically a clean build. Okay, so I've built Android for you, so that's why you will have the out folder. What did they build? Okay, so we'll talk about both the out and the device. So let's look at the device. Okay, so you can see that it's kind of divided into companies. You have Linaro, MediaTek, Google, TI, and all those. So we basically, if I would have a company, Samsung and all these companies, they have a folder here. And then this is the Google devices. So this is Android 12 that I download. If you would have download Android 13, you would have gotten the stuff for the Google Pixel Fold. But this is basically the code name for devices. So I think my Pixel 4a, I think it's Sunfish. I think it's Sunfish, Google Sunfish Pixel. I think it's Pixel 4a, yeah. And I think this is the Pixel, whatever. Anyways, so these are the devices we are building. We are building the Cuttlefish device. So let me find it. Here is the Cuttlefish device. The Cuttlefish device is basically a VM that runs on a kernel that you can customize, but it's basically a virtual machine. That's the big thing, and we're going to customize and build and customize the virtual machine. And I've done the build for you, and I will show you in a second. So how did I build it? You can see in the history, I did this command, which I'm going to show in a minute. So basically, this is the command. Source build environment setup is the command that you always do when you open a new terminal. Otherwise, nothing would work. And I'll do it now. Okay. So and I will also message you, or I'll put it in. It is basically in the material, but basically source build environment setup, and then we'll see what happens. Okay, so what did I use after I did source build environment setup? I loaded the environment, the Android environment to memory. Now I can do HMM. Okay, so this was, until I did source, I didn't have the capability to do HMM. HMM is basically a help to know all the commands you do, because you just loaded environment setup into memory. You don't know what command you have. These are the commands that we'll see in a second. Okay, so I'll go over HMM in a second, but one of the command is M. M is make from top of the tree. Make M or same thing. Okay. So regarding, there was a question, are you saying Android is not Linux? Android is definitely running on the Linux kernel. Bionic is basically a library. It's a user space library. So you have the Linux kernel, everybody using the Linux kernel, but on top of that, you have the glibc, which is basically a library that C can operate. So it has all the standard functionality that you expect when having C, print and so on. Yeah. Okay. So this is basically how I build. I did M, and let's see how many cores I have. So I can. Where is the material? So let me Cuttlefish. Okay, the device download, where is building, examining the build, start a Cuttlefish build. Should be okay. Okay, anyways, there's I have the command, I know where it is, I just didn't put it. You can see it in the history. Okay, so the command to check the CPU, I did it when I started to know how many CPUs we have. Okay, back to 13. Okay, so there are 16 cores here. I'm going to build on 8. I'm not going to build on 16. So all I need to do after I did source build environment setup, I need to do. I didn't talk about the command launch. The first thing you need to do is launch. Okay, so launch is basically selecting a device to build. Okay, so it will take a second. And you should do that too, okay? You should go into your AOSP, do source build env setup, and then do launch, okay? And it's basically, you decide a launch combo. It's not a spelling mistake. That's how Google put it, like you choosing a combo. And we'll see that in a second. It takes a second to select to load, but I think it should be any second now. Any questions so far? Okay, now every time you opening the terminal, you getting in, you start a new terminal, you need to do these two commands: source build env setup launch. Otherwise you wouldn't be able to compile, you wouldn't be able to do anything. Okay, so then launch menu, pick a combo, and then we can see that there are many devices. Here's our Cuttlefish, AOSP Cuttlefish. This is basically for x86. This is 64-bit. This is 32-bit. There's the auto version. There's the phone version. There's the foldable version. There is also my Sunfish here that I can compile. Now you can see that some of them say user debug and some of them engineering. And then there is user, which is not here, but basically engineering is basically root access by default. And then user debug, it's root access if you need. So you are more here, you're basically still debugging the system. So you need root access, you need to have everything open and debugging tools. And here you basically, just in case you need, you do that before release. And then when you build, you will need to build without user. Okay, so so this is basically the launch combo, and you can add versions yourself. I'll show you in a second. So I will choose 21, which is basically the Cuttlefish phone, which is the virtual machine. So I'll write 21. Okay, so I can also do launch 21, same thing. Or I can do launch and basically the name of the device I want to build. Just for reference, Cuttlefish, let me grab user debug here. Yeah, so you can see in Android products, okay, you can see that this is where you can define if somebody has an engineering build. So I can always add an engineering build if I want, or user build if I want. So I can just go here and change that. And this one I'll use engineering, and that will give me basically the build that I need. Okay, I need to I don't think it will pick up unless I update. I update. Oh yeah, it did pick up. So there you go. So now I added a build that I can decide. Okay, so let's go back, and I want to change it. I don't want this right now. Okay, so we'll remove the user, remove engineering, and just keep that. And I will do launch 21. After I did the launch, I basically can validate that this is basically the target product that I'm building. If you forget to do launch, what will happen is that you run out of space because it will build another device, and this build only has enough space for one device. So So in other words, if something takes too long, it's because you're starting a clean build on another device. So don't if something takes more than 10 minutes or something like that, just I don't know, scroll up and see if you've done lunch. Okay, so okay, and then after I lunch, I can actually write make -J8. It probably would not do anything, so you can just give it a go to see that the process, and then we're going to launch the actual device, the actual Cuttlefish device. I'll give it in the background. So, any questions so far?
Yeah, I tried lunch 21 and I got an error.
What was there? Did you do source building the setup?
I did, and then I did lunch, and then I did lunch 21, and it said, cannot locate config make file for product lunch 21.
Okay.
Dump files failed with exit status 1.
Okay. And what should what device are you?
4.
I will try. So I will try that. In the setup, lunch 21. Okay. Is that how you wrote it?
I think so. Let me go look at my history, but yep, that's what I did.
Course building lunch 21.
Oh no, I see what I did. Never mind.
Yeah. Okay, so I will take a second, and this should actually not build anything. So let's go back to. I can close this. I'm closing that. Okay, so the device folder. Okay, how long is that? All these videos I made.
Yeah. Let us go back to the AOSP folder and run ls to see the directory structure. For now, let's ignore most of these folders, but only focus on a single directory called device. The device folder is intended to host all the open source Android customization code. It is where we would add our own customized system service. In the Google folder, we can find the open source code for the supported Google phones for this checkout branch. The code name of these phones are named after a fish. For example, Redfin is code name for the Pixel 5.
Okay. This is not my voice, obviously. This is synthetic voice. So let's look at the Cuttlefish.
This year, we're kicking things off with.
For testing any platform code, we should start coding on a virtual device, and once the service has worked on the virtual device, we can add it to our target device service list. The Cuttlefish image is a configurable virtual Android device that includes all the framework code and any custom platform code like the one we are planning to add in this course. The Cuttlefish image is a replacement for the Android emulator for AOSP developers.
Okay, HMM command. Let's see that. This is the next one. Okay, this is good.
Let's go back to the AOSP folder. Before we can start the Cuttlefish image build, we will need to load the Lunch script along with other useful development tools so we can build Android. This is done by sourcing the build/env setup shell script. Now we can see the full list of available commands by running HMM. Let's go over a few important commands. The launch command will be used for selecting a specific image to build. We will use it shortly to select the Cuttlefish x86 user debug image. Android is made out of modules, which must have a unique name. The gomod command can show us the location of the settings app by just typing gomod settings. The croot command changes the directory to the AOSP directory. The m command builds the current directory. We will soon use the m command to build the full Android image by running this command from the AOSP folder.
Starting a Cuttlefish build.
To select a device to build, we will need to run the launch command. The script has parsed the device directory and found the following build combinations. For Cuttlefish, we have 7 build combinations. Notice that it is also possible to build the Pixel 5 codename Redfin using this menu. But that requires the device binaries to be in the vendor folder. We can see that combinations have user debug, or ENG endings. User build is for production build. It does not have root access, and the Android developer bridge, or HeyDB, is disabled by default. User debug adds debugging features. HeyDB is enabled by default. The HeyDB shell command will open the running Android Linux shell screen. If we build with user debug, we can change to root by running su. ENG build is similar to user debug build, but HeyDB comes up in root mode without needing to su. We will select the Cuttlefish image x86 build combination by typing 17. This number can change as more devices are added or removed, so it's always good to validate our selection. We are ready to start the build process by running the m-j command.
Okay.
Hello.
So
Communicate
let's up here. Let's see what happened to the build. Okay. So build completed successfully. I don't think it did anything, but where did the build go? So as I told you, okay, everything is going to the out. Okay. By the way, any questions so far? Let's see, there is a question. It says launch. No, okay, so Aniet, you need to source build in the setup.sh before you run the launch command. Okay, so you got to do source build in the setup. Okay, so let me know if that doesn't work. Okay, so this is the out folder. It has a bunch of files that we'll talk about the build system a little bit later, but sorry, I wrote it in the wrong place. Okay, so we have this thing called target. Okay, so all the files that go in that are in kind of target build is here. So all the target files, and then basically we have the output. So if you build another phone, it will be in our target product, but under a different name. The Cuttlefish called Virtual SoC x86. That's specifically for the Cuttlefish device, but it will probably be different for your own device. And then you have basically the images that you build. Okay, so these are the images which we'll talk about in the course, but the super image basically contains lots of images, not all of them, but there are lots of images. Not we'll go and we'll talk about the partitions, how they do in a bit. So if I go back, there is intermediate. Where's my intermediate files? Should remember it by heart. Sung. Okay, there you go. Sung, and then. Okay. Anyways, it's in the material. I just don't remember where the intermediate files are. I don't think it's doing UI intermediate. Okay, anyways, well, it's part of the lab. I just don't remember the path. Okay, so we are we have talked about the output files, yeah. So so target product VSOC. This basically contains what you need in order to build to flash the device. Now, one of the thing is the folders. So if you can see that there is this images, and they are corresponding to this folder. So basically, the system folder, which also corresponds to the system partition, is the system made into an image called system image. So you can see that product has product, RAM disk has RAM disk. So to know what is in the super image contain everything, but to go into what is in the system, you can just go here to the system, and that will be the same as your device. So your device will have a system folder, and this is the files that will be in the system folder. So you can see here that the apps that have been built for Cuttlefish. These are the apps that are built for Cuttlefish. There is a Bluetooth app. There is what else? All this app that you can see here. Okay, so these are the apps that are built in the system. And there's also privileged apps. Private app is privileged app. This has the shell. It has download providers, NTP service, MS, fuse location, sound picker, all this stuff. These are basically services, privileged apps. What else? What other apps? There are in the system folder. You will see that there are basically a framework. I know that it's hard to remember, or I don't know if you need to remember, but framework is all the Java libraries. Okay, so you will see all the Java libraries, the jar files. Okay, so these are the Java libraries, and then the libs are basically the SOs, the C++ libraries. Okay, so these are the C++ libraries. Okay, so these are basically system partition contain basically most of the operation system libraries and things. So that basically important to know. Xbin, here there is SU, and then there is bin, contain all kind of all kind of basically applications like unzip, unique, ulimit, so anything you need to do stuff on the OS and the command line is in the bin. Okay, and that's accessible. So if I run it and I run long name, I might be able to do it. Some of the stuff require SU, but obviously, if you want to play around, you have SU now. Okay, so these are basically the files in the bin. Okay, so you have the bin, which is all the binaries, the applications. Apex are also apps that come in with libraries. So these are basically Apex. It's a zip file that has bunch of stuff like Java library, C++ library. So you can and it's only for OS developers. Obviously, there is fonts. And then there is the etc library, which contains a lot of stuff about everything about the OS. You can find out a lot of stuff here. These are basically the all the information you can see here. Preloaded class. What are the preloaded classes that are coming into the OS? So basically, Zygote is a thing that will load those classes in order for you to have them later. You can use them as an application developer, and it's already loaded into the actual memory, so it doesn't take time. Yeah, so lots of stuff here, and I think that basically it. So system is the big thing. We'll talk about partitions. The choice is 18 cuttlefish. There's a bunch right now, but it shouldn't be 18. Okay, so there was the question of choice. So there's a bunch of cuttlefish. This is for 64-bit build. I'm building the 32. So choose 21. Okay, so choose 21 just because my lab is for 32-bit, but it doesn't matter. It's the same thing. You can choose 64. It will be good, but just in case, make sure you choose it's 21, which is basically 32-bit. Okay. Actually, you see, this is wrong. If I'll start building now, I will build for AOSP ARM because I clicked enter. I can just choose. Okay, I think that basically it. Let's run the virtual machine. So even if you didn't compile because you don't need to compile, I've compiled for you. So now we basically launch in the virtual machine and we're going to connect you to VNC. So we started the Cuttlefish build, and then we'll basically I had to set for you a cloud host setup. It's a way to run a Cuttlefish. Android 13 has an explanation on how to run Android 13. So this is for Android 12 only. But let's do setup, create, boot-in, a cloud create. Okay. So what you need to do after you make it, you basically need to run this command. So I'll put it in that, and then I'll put this here. Okay, so let's do launch 21, make m-j8, and then after you made it, you basically run it. So I'm doing this, and it should boot up. You should do that too, and then you connect to VNC, and we take a break. So I'll let you do that, and then run VNC once you have it. Okay, so we are back. Let's see where we stopped. We basically created a Cuttlefish instance that is running on the build we just did. And then we used VNC to connect to the IP and the port 644, so 6444. And then we can access the device, and we can use it, play with it. It's good for testing services that the Cuttlefish itself specifically is good for testing services that you are creating, and you might not have hardware or anything that you want to try on a VM before you start flashing real devices and debugging those. It's easier to debug because you build, you run, and you skip the flashing part. You do have a performance issue, obviously, but it's working enough to help you debug services and all this stuff, because most of the debugging is not done using UI. It's mostly it's maybe you start running a test on the UI, but you don't the logcat is the one you're interested. So the question, I have a question. I have a Pixel 4a phone. If I want to build locally, it's the same process, right? No, I suggest you to so if you if you want to build vanilla Android, okay, and not something like Lineage OS, so you can, but there's another step that is important to know. So if you want to build for devices, you basically need to do the Android device binaries, and it's in my material. Okay, so you would download the specific build that you want. So this is the tag, this is the build type. So this is based on the tag that you put, the branch you checked out, and then you would then click on the link, download the vendor image. You can see here basically vendor image. You download them, you put it in a vendor folder, you extract it, and it will extract to a vendor folder. And you need this. You need to agree to a license, to a terms of service, whatever, just to download it. So you need to go to the Pixel 4 here someplace. You will find the Pixel 4, and that's 4a, and that's what you need to download. But it needs to match. It must match the branches that that you are building for. So so it's just the link. I want to show you. Sorry, repo. Source code hasn't built. So if I want to build for the Pixel, the latest Pixel 4, this is the 5G. Okay, so this is the 5, still 5G. Okay, so there you go. That's basically Pixel 4a. And I can go to the latest one. Okay, so the latest one, I know it's kind of hard to see here. Not that it matters what it is, but I would choose this one. Okay, so this is the tag. And then I would find out, and that's the branch I need to check out. So I would check out the branch, and it also tells you that the latest Pixel 4a has this branch. And I would download the branch, and then I would download these two links, extract them, and run them. It's a script, it's a shell script you run, and basically you accept the terms, and then you build, and then you build everything and you flash it. That's how you build for a Pixel 4 device. Okay, any questions?
Cuttlefish has booted successfully, and the VNC viewer has logged into the device. We can now go to the Settings app. And in About Phone, we can scroll down to the build number and click 7 times in order to enable the developer options. Now the developer options have appeared in the System menu under the Advanced section. The menu is a bit jumpy.
So one thing, if you want to enable ADB on your device, okay, you need to go to the Settings menu. Okay, it's kind of depends on your device, but in most devices, Samsung, all those, you need to click 7 times on the build number.
And in About Phone, we can scroll down to the build number and
then you need to click 7 times.
Click 7 times in order to enable the developer options. Now the developer options have appeared in the System menu under the Advanced section. The menu is a bit jumpy. We should try to enable strict mode to see if an app runs long operations on the main thread. We should also enable the option to show backgrounds app that are not responding. And let's enable show taps to see a visual feedback for our taps.
So obviously you don't need to do any of those, and it's also once you create a new one, you lose that. Okay, so the next thing that we're going to try is back to the shell. And in the shell, you will do ADB devices to see the list of attached devices. We have a Cuttlefish attached to our VM, so we can do ADB devices. And if you click on ADB, if you do ADB, you can see that ADB stands for Android Debug Bridge. Okay, Android Debug Bridge. And it gives you a bunch of stuff that you can do that are a little bit more advanced. But you can do, in order to access a device, you can do U-S and the serial. Okay, and then that will give you access to the serial. So if I have ADB devices. So here is the serial. So I can do ADB shell. I actually don't need to put the serial. If I do ADB shell, it will go to the first one, the default one. I can do exit, or I can do debug -S and the serial. And then we call it serial, but obviously it's not. There can be serials with real devices. Real device will show you the serial number, and then I'm in the device. Okay, so I'm in the device. Okay, I'm basically in the Linux shell of the device, and I can click write ID, and that will give me basically give me. You can see here that I'm running as user ID shell 2000, running as group ID shell 2000. So 2000 basically the number of that user. Okay, so user Linux number for shell is 2000. And then the user, basically the shell user, because I'm entering as the shell user. The shell user is belong to these groups: the shell group, the input group, the log group, the ADB group, the SD card RW, and so on, net Bluetooth, internet, read proc, and so on. And then it belongs to the SE Linux context called shell. Okay, so you don't need to worry about what it says here. It's always the same thing, URS0. But basically shell is the context, the SELIN context that we are. Now, a lot of it doesn't mean anything right now. Maybe it means, maybe not. Those that are in Linux, they know what those are. But we'll see how everything I showed right now is connected in Android. So all these things will appear again and again, and it's actually the labs. We'll create a service that will have a specific context, a specific user ID. It will be system, and that's it basically. We'll see how it plays in the security in Android. Now, so I'm in the Android device Linux shell, and I can do SU because this is a user debug build. So I can now see that the IDs belong, I'm running as root, and I can go anywhere I want. The shell user, if I exit for a second, now you see it changes from $sign to pound. When I look at the files here, I see that I'm missing a bunch of stuff. I have question mark because I don't have SC Linux access to do that. If I go to the data folder, which is basically the user data, I'll speak in user data in a second, but basically this is where the files of the operation system, where it runs all the stuff that is collected, all the apps that are basically expanded, going to the data. What does it mean? And you can see, you can see that I don't have permission. Okay, so let me not branch out a second. If I go to do super user, and I'm a super user right now, I can do ls-l, and I can actually see the folders in the Android data folder. So before that, I couldn't because I wasn't super user. Now I can. Okay, so these are the folders there. So let's step back for a second. Okay, so so as you notice, I'm super user. I'm keeping myself as super user for now as root. So you can see the folders more clearly. These are basically the folders we saw before. We saw system and we saw system ext. we saw product, and so on. So all those folders were before. The system, okay, it's the same system folder I showed you when we were in the out directory, in the host computer. But this is on the device, and you can see that these are the same folders we saw before. So there's the apps, there's the binaries, and there's the framework, which contain the jar files, and the lib contain the SO files, the C++ libraries, the privilege apps, and the apps. Okay, so these are basically all the folders. Now this system is read only. Okay, so I cannot write anything. This is read-only file system. Okay, and this means that the system partition, okay, and the system ext, okay, and the vendor DLTM, and the ODM, and the OEM, and all this stuff, not data and not cache. Okay, those are write partitions. This, when you do a factory reset to your Android device, you basically delete the data partition and the cache partition. You format those. That's that, and the SD card. Okay, so that's also the important, and storage, which is the SD card. The system partitions and the system ext partitions, those images, they are kept. They cannot be touched. The only time they're updated is during a system update. When you update a system, that's when you can change it. If the system partition has been tampered with, the Android would not boot. It will give you a warning sign or an error sign that the system partition has been tampered and it cannot boot. So the system partition cannot be changed, and it's read-only. Any questions so far? Okay, so back to so kind of just to repeat, the data partition, which is the user data partition, is the only one that is writable. So you can see that it actually doesn't tell you much, because it tells you that system is writable, but it's not writable even by root. So it's not really good to see, but okay, so let me refresh your memory that when I entered data, so if I go into data and I do ls-l, I get a permission denied. Okay, you will see that the reason that I want to make sure that I don't jump. So yeah, this is more of talking about here. We'll talk about that tomorrow, but I'll remind you. I'll start talking about it now, and then we'll dive deeper later. You can see if you're not familiar with this, ask me. But basically, what you see here is the directories, obviously, and you can tell that these are directories because it says dd or link dd, and this is a file because it doesn't have anything. Okay, so this is a file, and you can see that that the rest of those are either directories or links. Okay, so the next group basically tells you what can the root, basically this is the user ID and this is the group ID, and what can the user ID do, and that basically corresponds to the next 3 bits. So the root user ID can basically read, write, and execute, and create. X is basically execute, sorry, with the directory. I actually I'm going to jump for a second for this slide. Okay, I just shouldn't have jumped here, but I basically I've done it, so I want to show. Okay, so this is what I'm showing you. Okay, the Linux file permissions. Okay, so the first one for file is dash for file, L for link, and here is dash for directory. And when we are talking about the directory, this is the user ID, which is system, and this is the group ID, which is system as well. You can see that the data partition belongs to user ID system and group ID system. The next three here are basically what can the user ID do. So read, user ID can see the list of objects, files, folders, links. So you can see the content. W, user ID can change, system can change objects in the directory, and X, user ID can go into the directory. Okay, so X meaning go. Same thing when we do the group, it's the next three ones is for group ID, RWX can do all this, and basically all the others that is not user ID, not group ID, this is basically their 3 bits. So anybody else that is not system cannot read, cannot write, but can enter the directory. And this is what happens when I go to data. Obviously, I enter the directory. I'm inside the directory, but I cannot see the file, and I cannot write into anything because I have a permission denied. And this is because the next 3 bit, these two are turned off, because if I go back here, okay, so this is the data partition, okay, belongs to user ID system, group ID system, and those are basically, this is for the user ID system, so this is system, this is for the group ID, and others have no access to read, no access to write, but they can enter. That's why I was able to enter. If I change, if I use a system, I can do an ID. And this is only because I have a user debug build on a real production device. You don't have that way, but this is for debugging. And you can see that the user ID is system. And now I can basically list the content because I'm a system user. I basically did SU as system. And now I can list the content. I will exit. We'll go back to the device and we'll talk more details about how it's built. But let's still kind of see what is HMM. This is, I exit the device. I wrote exit, and I can see basically the things that I can do, and I'll go over the big things. So M itself, we said it's building. Build and install all the modules in the current directory and the dependencies. This is if you're working on a directory, we'll see that when we do the lab, we'll use for building in the current directory instead of going to the main build. This means that you can build module. The difference is that M itself basically builds the super image, which is the one that you actually use to flash the device. And MM does not package the super image. It just builds a module in the current directory, but not using M, so it doesn't package it. So this is for an internal build, for if you are testing if something works. M is if you want to package, it takes much longer. Most developers use MM. When they're good, they go back. You have all kind of greps to look for something. So if you're looking for C++ files using cgrep, Go file, Java file, Kotlin file, resource file, manifest file, make file, Rust file, SC policy file, and so on. This is basically go to directory containing a file, list all modules, and gomod, go to directory containing a module. So let's see. So let's say I do all mode. Okay, I get all the modules in the system, and then I can maybe grep it for settings. Okay, so this is basically settings, and this is if I do gomod settings. Okay, go to the model. I'm in the settings app. Okay, so basically I'm in a folder called packages, which contains a bunch of apps. I'll show you in a minute. And I'm in the settings app. Okay, so this is basically the settings app. And I can search for calculator. Okay, calc maybe. Calc. Maybe not. Browser. Okay, so there is the browser. I can go mod browser 2. And now I'm in the browser 2 application. So these are basically the source code of the applications. This contains all the source code of the browser. Okay, so this contains Java files in this because it's pretty simple. It's just a web view. And if I go to settings, you can see it contains a bunch of Java. The actual settings app that we just had open. And if I search maybe 7 times, let's see if I can find something. I don't know if I spelled it. If it's not. Anyways, it might be something times. So yeah. Anyways, I can do for that, to search for that specific thing, I can do a resource grep. Okay, a resource grep, and then write times. Let's see if I find something. Click. Yeah, might not have it. Okay, so this is basically the supported languages. I don't know I don't remember the exact error code, message, so I can find it. But so this is basically the text you can see when this is whatever accessibility screen magnification, short summary, and this is the text. Tap 3 times zoom. Okay, so this is basically all the strings we can see. Now this is the key. Okay, so this is the key, and here you can see, and this is basically porting, and yet basically porting it to his own language. So you can see that every language in the settings app, okay, that is supported, you can see all the translation for that. Tap 3 times. You can see that the default one is res, inside res values strings XML. And then for Armenian, I guess, I don't know what is IR, but French, this is the file for the French. So it's an XML on the French. So you have all the translation of all the apps. And if you want more languages, you would need to support and create a string file for your app with the same key. Okay. So yeah, chat question. Let's see. I missed the search for languages, please. So so all I'm saying, and we'll go over it more. We looked at the settings app here, and you can see that in your res folder, you can see that there is values, and if I go to the values French, I can see all the strings that are the translation for the French language. Okay, so this is all the translation, and these are all the keys. If I would want to create a new language, I would copy the default one and make. This is just one part. There's more things to do, but and then do the ISO code, 2 letters code here, and basically copy and update all the values to the language that I want to translate, and I will do it for any app that I want to do. So basically create whatever language you have here and then copy it, and basically you in Vice there's quite a lot, so you only need whatever the French has. So the strings, I think, is the only thing you need. So these are the strings. Okay, we'll talk about it more if you have any questions, but these are basically how to translate your app. Okay, back. So we used HMM. Okay, we used HMM to grep or basically store the commands, and then we used allmod to list all the mode, gomod, and then get the directory containing, get the location of the module in stored output with certain. So let's do outmod and then do settings. Okay, so let's see. So it tells me that the settings app, okay, so this is the settings source code. This is where the Java code or the C++ is. But when I clicked outmod, I can see that these are the files that have created for the device. So you can see that the settings app is sitting in system_ext partition. Inside privileged app, there is settings, and then in setting APK. Okay, so this means that if I go to system.ext, okay, and I will go to privileged app, okay, I can see that there's the settings app, there's the storage manager, all kind of stuff, the launcher, 3 quick step, but this is the settings, and this is, if I go here to the settings and I see what is inside, I can see that there is the settings APK, which is basically the actual the zipped app, and then there is basically the source code, which is called optimize Dalvik executable. So if I looked at the size here, probably most of the code is in here. I can unzip it. So this was in my my device. The same file, okay, so I don't know if you catch that or not, but the same file exists in my out target product on my host, right? So before that I was in my device, product VSOC. Now I can go to the same location, system.ext. Okay, so it's not the same physical file, those are two files, but it's a copy, right? And then I can see here the settings APK. Okay, so that's the settings app. Now I can do things. Let's say that I go, I'll make a temporary directory just for the demo. Okay, so I can pull the application from the device using ADB pull. Okay, so I do this, settings, and then settings APK. Okay, I can actually pull, and this ADB pull works on non-rooted device as well. If you want the Facebook app, if you want any app that you do this, you do basically ADB path. I'll show you this in a bit, but I'm not going to, I wouldn't confuse you yet. So anyways, this is the settings APK. Okay, so what did we see? We see the settings source code. Then you compile the source code into the out target product, and that's basically how did we find the location? We did outmod, and then I know that this is the output from the building of that APK, and I can copy it from here, or I can extract it from the device because it's also on the device in the system.ext partition in the privileged app settings APK. So I've extracted the APK. The APK is the app. Any questions so far? I can unzip the APK. APK is basically a zip file, a line zip file, and I can see the content of the application. This is every application. You can do this. You can do to any application you download at home to your Android device. You can download the application, extract it, and unzip it. You don't need to be root. Any phone will work. So, you can see that this is the setting APK that I've downloaded, extracted from the device. This is the classes, and there is basically the Dalvik executable, which means that this is basically Java code that is compiled into what's called the Dalvik executable. So the question is, I thought the APK files were encrypted. No, APK files are not encrypted. There's encryption inside you can add to remove the encryption of Java code, because this is basically what happened is basically in the history of the Android, when it was first created, they decided not to use the Java runtime. So Java runtime is when you write Java and then you give the class, right? And then you run it, not the Java C, not the compiler. Okay, so it's not the Java C. So it's the Java that you run, okay? Or you run a jar, right? You basically run Java. What is Java? Java is basically the Java runtime. It runs your command. It's a C++ application that basically runs your Java class. Okay, it executes it. Android have Dalvik and Art, and so when you see DEX, it's like basically seeing a class in Java. It's the compiled Java source code into Dalvik executable bytecode. So this is basically executable bytecode. It's code that you can I can probably don't have Dex interpreter. I don't have that. I need to. There's basically a way to look at the Dalvik. Anyway, getting too deep into stuff, but that's basically it. You can later how do you call it? Reverse engineer this. These are the resources, images, layouts, and so on in the resources. Maybe music. It looks big, so it's probably, I think it has some music in there, some ringtones and so on. So this is just the anatomy of an APK. Now, if you are trying to cut anything like the Android manifest, this is what you get. It's because we didn't basically this is binary format, but we can convert it. There's a way to convert it into source, basically text, using APK tool. APK tool will do that for you. But let's not get into that. Okay, so after the break, okay, so we talked about outmod, we talked about gomod. Anything else that I wanted to talk about? Yeah, so I think anytime that you in the AOSP and you want to reach the root folder, so you basically do root. It's very useful to go back to the root. Okay, so we are back here. Let's watch this video.
The build has finished successfully. It took 6 hours and 47 minutes on a strong MacBook Pro. We can see that a super image has been written inside the VSOC folder and is ready to boot. The name of the folder is set by the board config mk file inside the Cuttlefish folder using the target board platform variable. The super image contains the system, vendor, and product images. The super image is 6.5 GB in size, and it is read-only. The writable user data image is the partition the system will use to unpack apps and save databases. It is also 6.5 GB, but it is currently empty until the system boots for the first time. Let's run the du command again to see what is the size of the AOSP folder. We can see that the size has grown to 200 GB.
Okay. Let's go back. Let's go back to the material. Okay. Let's finish today's material by talking about those folders and the device configuration. And then tomorrow we'll do the security a little bit more, dive deep. So I'm not going to do it today. I'll just finish the material here. Okay, so where was it? Base core. Okay. Start with this one. Okay, so back to developer.android.com. Okay, so as you guys remember, there's two websites. Source is for the OS, and developer or d.android.com is for the developers. And if I go to the service we already looked, which is basically the Android OS vibrator, okay, or vibrator manager. These are basically the functions, and we can see that this is basically in Java. Okay, this is basically called the package. Okay, so we have the class, which is vibrator. Okay, so this is the class name, so it's vibrator.java. And then this is the packages. Packages in Java are one-to-one basically directory. So you have to have, in Java, you have to have a directory called Android and a directory called OS. And inside that, there will be like a vibrator, a Java file. So this is easy to see. So in the Android AOSP, there's this folder called framework base core. Okay, so frameworks is basically the OS, the framework. And there's base and core. That's how they named it. And whatever is in core is actually in here. Okay, so if I go, there's more places, but if I go here to Java, okay. So I'm in Java, so now I can go to Android and I can go to OS and I will find the vibrator class. So I go to Android and I go to OS, and then I find the vibrator Java file. Okay, so there's the vibrator Java file. Okay, and this is the same one that was used to generate this Java doc. So you can see the docs here. Doxygen. So you can see here that this is basically the text that has been compiled. So this class, the text basically created this HTML. Okay, so all this HTML exists in here. Okay, so turn the vibrator off. This is basically the function cancel. Okay, so cancel turns the vibrator off. This is the cancel function. Okay, so I can see here cancel and the cancel function, and the cancel. Yeah. How did I get here? Okay, so why did you do that? To cancel here. Okay. Anyways, this is the function. So I can find that function obviously here. So this is the function. So this is basically, if you go here in the OS, you can go into different basically files. You can find them here. Okay, so this is basically you can see here all the stuff, all the source code for this is basically beta usage stats, and it's not really the source code. It's basically well, there is a little bit obviously of source code. There is Java code here. There is this AIDL, and there is this Java codes. Okay, and they are pretty small. You can see that these Java codes are pretty small. Okay. So what is those Java code? I mean, there is vibrator, but if we look at the vibrator, let's look for the vibrator here. This is vibrator. It's pretty small. It just contains a bunch of functions, and then there is vibrator manager. So if I open the vibrator manager, okay, so if I go to cancel, okay, it's also abstract here. Vibrator, what is it? Vibrator manager, and then vibrator, and then there is system vibrator, right? There is system vibrator. Okay, so the source code for the vibrator is here. It's basically just extends system vibrator extends vibrator, and then it has the cancel function. Okay, so this is the cancel. This is all the cancel function. It's called vibrator manager dot cancel. Okay, so vibrator manager dot cancel, and what is vibrator manager? Okay, so let's go in class. This is the Java class. Okay, so it's a class system vibrator, and it extends the vibrator, and it has my vibrator manager object. Okay, instance. Okay, so that's where it is. And in the constructor of the system vibrator, so this is the constructor of system vibrator, this is the constructor of system vibrator. It basically initialized the my vibrator manager. It's initialized it to this thing called context get system service vibrator manager class. We still don't know what it means, but basically this is the beginning of the discussion of how Android is developed. This code, okay, the system vibrator, okay, this code that appears here for the app developer, not all of it, but all these functions, they basically run on these things run on your application context, application memory space. What does it mean? When you develop an application, okay, so when you develop an application, a game, and you need to vibrate, okay, so if you look at the boundaries of your application, then you need to call this function to vibrate. You need to ask for the system, the operation system, to do something. It needs to go to the hardware and vibrate and actually move the motors. So there is a point in time that you are needing to leave the memory of your application and go to an application that actually has the permissions to actually talk to hardware. Okay, so use an application, you don't talk to the kernel driver and ask it to vibrate. Not in your application process, not in your memory space. You will ask for something called the system server. The system server is a process that is running. Okay, so ADB shell. if I do, oh yeah, I was in the wrong shell. Okay, so if I do ADB shell over here and I do PS minus A, or PS minus capital A, I see all the running processes, okay? All the running processes, there is gallery, there is messaging, there is settings app, okay? So why do they look like that? Well, we didn't talk about it, but Android applications, okay, they have the name settings, but it actually looks like this. It's not Java package, it's just basically a name. The name of your application is com.android.settings. That's the name of the application. There can only be one application on the Google Play Store to have that name. I'll show you. If I go to Facebook app, Android, okay, so I click on this one, you can see the name of the application, com.facebook.katana. Okay, that's the name of this Facebook application. com.facebook.katana is the name. And you would, if you would have listed using PS minus A, you would have listed the running processes and Facebook would run, you would see com.facebook.katana. Okay, so these are the name of the applications. Any questions so far? Okay, so there's all these things that are running. This is the applications. And then there is this binary, this executable, this C++ code. And then there is like this thing called system server, which I mentioned it just a second, but I'll go back. And then there is more stuff. Okay, we'll go back. I'm not going to go over all the stuff right now, but you can see that the first process that started the system is init. How do I know? You can see that it has process ID 1. Okay, so you see that this is the number one process. It's the first process that was created. Then there is a bunch of kernel processes, and you can see that there is another init, and you can see that this init process is process ID 150. And this is the process ID. And the parent process ID, okay, both of them start from 0, the K-thread daemon for kernel, and this is the Android 0, okay? Both of them, okay, so this init, process ID 150, started from process ID 1. What is process ID 1? Process ID 1 is this init. Okay, and then you can see U-event daemon, some kind of process, to has basically process ID 150 and started from the init. And then we have log daemon 174 started from the init. Low memory killer daemon, when you run out of memory, this is starting from 175, started from the init. Volume daemon, the one that loads your volumes, your SD card and so on, started also from the init. And so on. This is the parent process, and this is the process ID. We'll jump down into Zygote, and we'll talk about this more in class, in the course about the put process. But you can see that Zygote also started from the init process number 1, and it has process numbers 357. And this Zygote, you can see that it's running as root. It's running as root user. Now, if we go to the applications, okay, so we have the settings app and the gallery. Those are basically user ID 3031 and settings is user ID 3155. But these have started from 357, which is Zygote. We still don't know really what is Zygote. Okay, so this is started from Zygote. Zygote started from init. Okay, let's step back. So we have these applications that are written in Java. We saw that settings is written in Java, okay, and they compiled and they are started from 357, which is Zygote, okay, and then we can see that this settings is a system user ID over here, okay, so this is system user ID. We'll talk about those tomorrow. I don't want to overload. But what I did want to talk today about system server. You can see that system server basically is user ID 578. And you can see that there is a little bit of bump. So 578 suddenly 1733. The reason it is because this has many threads. System server has many threads. We'll see those in a second. So then the thread also count. The thread number 578 is basically the main thread. We'll see that in a second. And then there is basically like 1,000 threads. And then you continue with this one. So this is basically a system server. It's a process, and it's belong to the system. Okay, so why do we need all this stuff? Why do we care? Well, first, only because you're interested in knowing about the Android OS, but the second reason is because this is all connected. When you are basically using the vibrator in your application, you are calling this function in your application. You are basically executing vibrate function in your application. But yeah, I already had this open, so right when you call in the actual cancel function, you call in this thing called vibrator manager, which we'll dive later more into how this happened. But this vibrator manager basically will leave it's basically a proxy. Okay, so this cancel is basically going to leave your application using a proxy, and it will talk to the binder. It's going to talk to the kernel driver called the binder. And this function will pass through the binder from your process, which is your game, whatever it is you developed, will leave your process, jump into be copied, the content, the function number will copy, and we'll see that in the next session, will copy the data from your process to the system server process. Okay, so that's the system server. This is the one. Okay, and in the system server lives what's called the vibrator service. Okay, so what is that? Okay, so I don't know if you're interested, but I'll tell you anyway. So we are leaving this folder. Where are we? We in base core Java Android OS. This is basically the code that goes into the SDK, the software development kit for developers. It doesn't have code to actually vibrate. It basically has code to only message the system that it wants to vibrate. The code to vibrate does not exist for developers or in this developer, because the developers don't care how Google wrote, the Android team wrote the cancel function. They don't care. They just need a function. So we have a thin layer in your app that calls the cancel through a binder. The binder is basically a kernel driver that copies this content or this whatever you pass to it to the other process, and the other process is the system server, which the system server code sits here. So if I look at the threads, let's look at 578. So let's look at -t for all the threads, and I think I can do process ID. Let's do -p. Look. Okay. So this is basically system server. I basically told to print all the threads minus T to process 578. And you can see that this is system server, process ID 578, thread ID is 578. So this is the main thread. The main thread in an application is the thread that basically responds to the UI. You press a button, you need to take it from the main thread and move it to another thread as fast as possible, because that if you block the main thread, the UI does not respond. This is the main thread is also the one that draws on the screen. So if you block it, if you write code that blocks it, you block the main thread, the application hangs. That's why you have a bunch of other threads, okay? So you can see that system server contains all those services: overlay manager, sensor service, account manager service, settings provider service, alarm manager. So I basically look at the Ethernet service and so on. So we have basically all the services. And this is a Cuttlefish, so I don't think it has a vibrator service, but maybe it does. Let's see if I can find it. Minus I has to have something. No. Yes, minus A minus T. Vibrator. Let's see. No. Okay, it doesn't matter. This is just for an example, but basically you have all the services, and the source code, as I showed, the source code for the proxy is in here, but the actual source code for those services, so the actual implementation for the vibrator service is in here. So in here, framework-based services. Okay. So let's go here. So I'm in services, and here we can find, if I search for a vibrator. Okay, so we have a bunch of tests, but here we have basically we can find the vibrator manager service. Okay, so if I open that up. Okay, and then I go to cancel. Cancel. Oh, was that it? Maybe it's run cancel. Okay, maybe it's run cancel. I don't know. Cancel vibrate. This is the cancel. We'll follow this path, but right now it's less. We don't want to get into the weeds here, but basically the services, as I mentioned, the source code for these guys are, or some of those are basically in core Java, in basically base services. So this is the code for the services. This is what will talk to the kernel. It will talk to library, and then the library will then talk to the kernel. So what do I want here to show? That we can see, okay. To wrap it up, so you can see that the system server running as a user ID system, okay. And now we are back here. Remember that basically user ID system, okay. So let's go back here. We can look at the system partition or the data partition. You can see that the data partition, the one that we weren't allowed to watch, we weren't allowed to lift. Who can access the data partition? Well, you can see that system has access. Okay, so remember, this is basically the user ID here, and this is basically the corresponding permission. So we can see that system user ID, which is the same as group, but it doesn't matter, they both are equal, has read access, write access, and a way to go into other folders. Okay, enter directories and enter into directory. So we can see that this system can do. Let's see our app. So if I look at the applications, well, we haven't created an app, but your app that you're going to create will not going to be running a system like settings. So system server, there it is, running a system user ID. Settings running a system user ID as well. But all the other apps, look at that, they running as this user ID. So it's each one has its own user ID, which means that they are not system. So these user ID are not system. They are different user ID. So your application runs on a different user ID than system, which means that it cannot do things because it, at least in basically it cannot do things that system can do. Okay, so if we look at the folders, we can see that there is basically different permissions. There is basically permissions for the shell and permission for the system, and there are different permissions for different things. If we look at the system partition, okay, we can see that everybody can read it. So I don't need to be root to go into the system partition and read it. I can be anybody, not a rooted phone. I can basically read the system partition because, as you remember, this is the user ID, this is the group ID, this is the third, and this is the others. And because there is a R in here, it's read access, so I can read the system partition. And this means that any app, okay, why am I actually talking about apps? Because apps, right, they are not system, there are others, so they can, every app can list this directory. Okay, so an application running, this is application, they're running as those user IDs, they can see what is in the system because it had basically, we saw that it had read permission. So any app can read from the folder, but there are things that you can't, right? So you can see that here on APX, yeah, every app can go read the content of the APX. Okay, so there it is. I can see, and I can actually cut it. So you can see that any application that is not root, you don't have to be root to cut this apex. I don't want to see it because it will go crazy on me. So we can see that there are things that are not allowed, like build prop. Nobody can read a build prop, and that makes sense because the build prop will tell you a little bit more about the device, and we don't want any app to track you. So this is basically the build of the device. So there is basically the release. You can see what is the information about this device. We haven't talked about props yet, but properties. But yeah, so it doesn't have read. The only user ID that can read the build prop is root, which means that even system server, which is running as a system user ID, cannot read it. So even if I log in as a system and I try to cut the build prop, I have permission denied. So there are files that even system server cannot do, cannot see. If I go to etc, okay, so if I go to etc, I can basically read all the stuff. Every app can read all this information on your device, but it's not true because there's another layer called basically DSC Linux, which means that there's things that I cannot read. So it's not like system, it's not like I can access it, but in this security level mechanism, I can. There's other security level called DSC Linux, Security Enhanced Linux, that prevent this kind of stuff. So, but this is at least from ADB shell. That's what I can do. Okay, so what are we learning? Basically, learning here that there is this big thing called system server, and it's a different process. And each application that wants to do something in the Android OS or something, or needs to do anything, they will talk to system server. Okay, there are other services that are outside it, but system server is the big one. You want to do something, you're talking to the system server. System server contains also the activity manager service and the package manager service. The activity manager service, and we'll talk about it more later, is responsible to start all this application. So system server also start all those applications, stop them, kills them if it's running out of memory, and so on. So this is basically the big thing about the OS. There's all kind of things you can see, like camera server, things for the camera, and then there are basically all the services here. These are basically the how. This is the hardware. So system server is very Java. It has C and C++. It has C++, but most of the libraries that work with the hardware, you can see here the graphics, the camera, the Bluetooth, and all those things that are heavy on C++. Those are basically in these services. And basically that's it. We'll go over more into details about all this stuff. So I'm going to pause soon. The key thing that you need to understand today is that we're going to write an application. Okay, and if you write an application and you use Vibrate, you use anything, you use in system server, but this is not what we're going to do. We're going to create a system service, one of those guys. So basically a system service that will run, and our application will talk to the system service.